Welcome to Wildcat Science with Mrs. Haugo. This is Chemistry, Chapter 11, Section 1, and we are on our fourth calculation, which is learning how to do mass to mass calculations, which is basically putting a mass to mole and a mole to mass calculation back to back. So please write this down. We're going to go from mass of your known quantity to moles of your known quantity to moles of your unknown to mass of your unknown. So this is the most practical type of problem because we need to know the mass of the products and we need to know the mass of the reactants in grams. So they're going to react in mole to mole ratios, but we can't really measure out moles in a lab, so it's good to know how much do I need to put in and how much am I going to get out. So please write that down. And the steps how to solve a mass-to-mass problem. First thing we're going to do, as always, is write a balanced chemical equation. Then we're going to find the molar mass of our known quantity, which is actually 1 mole over your molar mass in grams. Then we're going to figure out your mole ratio, and as always, you put your known quantity on the bottom, unknown at the top. But we also have to find the molar mass of our unknowns. We have to find the molar mass of both compounds. We're going to set up the problem and calculate. So your mass of your known over 1 times 1 mole over your molar mass of your known quantity times your mole ratio of your unknown over your known, and the molar mass of the unknown over 1 mole equals the mass of your unknown. So let's do it. Please write this problem down. In the decomposition reaction, how many grams of ammonium nitrate are needed to produce 33.0 grams dinitrogen oxide? Hint, water is the other product. So take a minute to write that down and then we're going to solve it. Okay, the first thing we're going to do is write down what we know. So we know that we are looking for how many grams of ammonium nitrate. And we know that we have 33 grams of dinitrogen oxide. So we have 33.0 grams of dinitrogen oxide, and I want you to figure out what that formula is. If you said N2O, you would be correct. And then we're trying to figure out the number of grams of ammonium nitrate. And I'd like you to figure out the formula for that. If you said ammonium nitrate, NO4, NO3, you would be correct. Then we're going to calculate it. The first thing we're going to have to do is write a balanced chemical equation. So what are the reactants? So in a decomposition reaction, so we're going to have more products than reactants, how many grams of ammonium nitrate are needed to produce? So ammonium nitrate is a reactant, and then to produce dinitrogen oxide. That tells us dinitrogen oxide is a product. And it also tells us water is the other product. So we're going to start out with ammonium nitrate, which we know is NH4NO3. And we know we're going to have dinitrogen oxide as a product and water. All right, so ammonium nitrate decomposes into dinitrogen oxide and water. So I want you to go ahead and balance that. So first thing we're going to look at is the nitrogens. There are 2 on this side, 2 on that side. Then let's look at the hydrogens. There's 4 there, 2 there, so I'm going to put a 2 there. And then let's look at the oxygens. I have 3 here, and then I have 1, 2, 3. Okay, so it is balanced. Great. Then I'm going to look at states of matter, and it's a decomposition reaction. So I'd like you to think about what the states of matter are. If you said that ammonium nitrate was solid, you would be right. If you said water was liquid, you would be right. And then this one is a molecular oxide, which is a gas. So that one's a tough one. All right, so the next one we do is we find the molar mass of our known quantity. So let's go back up. Our unknown is the ammonium nitrate, and our known is the dinitrogen oxide. So I would like you to figure out the molar mass of dinitrogen oxide. If you got 44.02 grams dinitrogen oxide, you would be correct. Then we're going to find out our mole ratio. So we're going to go with the unknown, which we know is our ammonium nitrate first. So we're going to go moles ammonium nitrate over moles of our known, which is our dinitrogen oxide. And we got to go look at our balanced chemical equation for that. And for every 1 mole of ammonium nitrate, there is 1 mole of dinitrogen oxide. So that's easy. Last thing we're going to do is we're going to find the molar mass of the unknown, which is our ammonium nitrate. So I'd like you to find its molar mass. If you got 80.06 grams, you would be correct. Okay. Then we're going to set up our problem and calculate, which is the mass of the known over 1 times 1 over our molar mass times our mole ratio times the molar mass of your unknown. So first off, our mass of our known quantity is 33.0 grams dinitrogen oxide. 33.0 grams dinitrogen oxide over 1 times our molar mass. So I'm going to do 1 mole dinitrogen oxide over the molar mass of dinitrogen oxide, which was 44.02 grams. That into a 4. 44.02 grams dinitrogen oxide times my mole ratio, which I remember was 1 mole ammonium nitrate over 1 mole dinitrogen oxide times my molar mass of my unknown, which is going to be ammonium nitrate. So that's over 1 mole ammonium nitrate. And the molar mass is going to be 80.06. Ammonium nitrate. All right, so then I cancel my units, grams dinitrogen oxide, moles nitrogen dioxide, moles ammonium nitrate, and I'm left with grams ammonium nitrate. And then I want you to do the calculation. Okay, so I got 60.018 grams ammonium nitrate. So we're going to go through and see if we got the correct answer. So we'll go back up here, and it said how many grams of ammonium nitrate? And our answer is grams of ammonium nitrate, so that's great. And then looking here, we had 33 grams of dinitrogen oxide. So we know that 1 mole is 44 grams, so that's about 3/4. So we have about 3/4 of a mole. So then if I have a 1-to-1 ratio, that means I'd have about 3/4 of a mole of ammonium nitrate. and an entire mole is 80 grams. So what would be 3/4 of 80? 60. Did we get around 60? We did. And then let's look at our sig figs. So put that your answer into the correct number of sig figs, which is 3. So 60.0 grams ammonium nitrate is our final answer. We checked it, we answered the question, and it was reasonable. Good job, everybody. Now you're going to try. So I want you to write that down. We'll get it back there. Tin 2-fluoride is made by the reaction of tin with hydrogen fluoride gas. Hint, the other product is hydrogen gas. If 30 grams of hydrogen fluoride are reacted, how many grams of tin 2-fluoride are made? So you'll want to write down the problem. I know it's a long one, sorry. Then you'll want to go through the steps, write what you know, write a balanced chemical equation, and find your molar masses and your mole ratio, and set up the equation and get your answer, and we'll go over it. So you should do that, and we'll go over the answers in class. All right. In our next video, we're going to learn about percent yield. I'll see you then.